So we're going to talk about absolute value equations and inequalities. And we need to start out by talking about the definition of absolute value. And absolute value is the distance away from zero. So when we look at these first two examples, we have the absolute value of -9 and the absolute value of 9. And if we were to put these on the number line, if we put -9 there, when we look at the distance that it is away from zero, that's going to be 9 units. So that's why the absolute value of -9 is +9. Okay? We do the same thing for 9. We put a point at 9, and then we do the distance away from 0, and it again would be 9 units. So that's why the absolute value of 9 is still +9. And we just did that by using the definition of absolute value. If we take a look at some more examples, a little bit more complex. In this first example, we have the absolute value of x plus 3 is equal to 8. When we're solving a problem like this, we're going to go ahead and isolate the absolute value. Okay? So let's make sure we put that down, isolate the absolute value. When I say isolate the absolute value, what I mean is get the absolute value by itself first. Okay, so we're going to do that by subtracting 3 from both sides. We would have the absolute value of x is equal to 5. And again, it's a distance away from 0. So when we look at this, it's actually going to be x could be 5 or it could be -5. Because the distance that x would be away from 0 being 5 units, we could go, I'm going to use a graph up here. If we had -5, that would be 5 units. And if we had +5, that would still be 5 units. Okay. So either way, it's 5 units away, so that's why 5 or -5 would work for this particular problem. The next example, again, we want to isolate the absolute value, so the first thing that I'm going to do is add 1. Bring everything else down. It's 3 times the absolute value of 2x plus 6 is equal to 9. Okay. We're still trying to isolate the absolute value, so I actually need to take and divide this by 3. Okay, that cancels out that 3. We have the absolute value of 2x plus 6 is equal to 3. Right, the next thing that I'm going to do is I'm going to rewrite this so that I have 2x plus 6 is equal to 3. Or I could have 2x plus 6 is equal to -3. Now I'm just going to solve each one of those by subtracting 6 and then dividing by 2. So we're going to have -3 divided by 2, and it would be -3/2. On the other side, we subtract 6. 2x is equal to -9, divide by 2, and x would be equal to -9/2. And that's the word or. And as you can see, both of our answers this time are negative, which is perfectly fine. It's just the way it worked out. We don't have to have a positive and a negative answer. If we wanted to check our answer, we just substitute back in and make sure that it equals out to the right-hand side. And when we did that, if we did that, both of those values would equal out. So both of these solutions are fine. Okay, we'll take a look at the next example, and we're going to do the same thing that we did in the last example. We subtract 7, we end up getting 2 times the absolute value of 3x minus 2 is equal to -4. Then we're going to divide by 2, and again we're just trying to isolate the absolute value. And so we end up with the absolute value of 3x minus 2 is equal to -2. And if you remember correctly, the definition was that it was the distance away from 0. But distance is always positive. So in this case, when we have it set equal to this negative right here, and the absolute value is isolated, when that happens, we're actually going to have what we would call no solution. Okay? There is no way possible that we could be -2 units away from 0. So when that happens, we would just have no solution. Right? We're going to move on and talk about inequalities. So we're going to solve this inequality where the absolute value of 2x plus 3 is greater than 11. We're going to have 2x plus 3 is greater than 11, or we're going to have 2x plus 3 is less than -11. Rewrite that. Okay. Make sure that you notice what I did there. The first time I solved it exactly the way that it was written. The second time when we did that, we actually switched not just the inequality, but we also switched and we made this negative. Okay? So when we're solving the absolute value inequalities, we need to make sure that we're doing that. We're going to solve them the same way after that. We subtract 3. 2x is greater than 8. Divide by 2. X is greater than 4. On the other side, do the same thing. Subtract 3. That way 2x is less than -14. Divide by 2 on both sides. Maybe x is less than -7. Okay, so even though the 14 was negative, because we divided by +2, we're not going to switch the inequality back. Okay, we would only do that if we were dividing by a negative number on both sides. Okay. I'm actually going to go ahead and graph that just as a kind of quick review on what this graph would look like. Because it's the word "or" in between, we're going to talk about what that looks like. So we're going to have x is greater than 4, which would be going that way, to the right, open circle going to the right, or x could be less than -7. Okay. So possible solutions would be -8, -9, -10, so on and so forth in the left-hand direction. Or we could have 5, 6, 7, 8, 9, 10, and so on and so forth, 11, 12, and we could keep going. All right? But we could check those by plugging in those numbers and making sure that they work. And of course they will. The last problem that we have is an application type problem. It says a company makes a bag of potato chips that weighs 11 ounces. Okay, that's a key word in there. Not all bags weigh exactly 11 ounces. The allowable difference from the target weight is at most 0.1 ounces. Write and solve an absolute value inequality. All right, so we're going to have that it has to be within 0.1 ounce of 11. So the first thing that we're going to do is to write the absolute value inequality. So we have that the bag is supposed to weigh 11 ounces, and it has to be within 0.1 ounces, all right, or 1/10 of an ounce. All right. So this is what we're going to have, and because it's less than or equal to this time, we're going to rewrite it that way, but then we're going to have the word "and" this time in between, and that's because it's less than or equal to, and we'll talk about that more in just a minute. So it's going to be x is greater than, or x minus 11 is greater than or equal to -0.1. And we're just going to solve those, add 11. So x would have to be less than or equal to 11.1 ounces, and x would have to be greater than or equal to 10.9 ounces. Okay, if we make that 1, it's going to be x is less than or equal to 11.1, but x is also greater than or equal to 10.9. And that inequality right there would show the allowable weights. Okay. The last thing real quickly, when we're talking about absolute value, less than or equal to, those are and statements. When we're talking about compound inequalities, we have absolute value being greater than or equal to. That's when we have the word or. So there's a lesson on absolute value equations and inequalities.